go over these because I think you've seen them before. Okay, we're talking about like patterns that we can see, and I'd imagine you're probably going to see some of these on EQAO on Thursday. And then I don't think they're overly difficult. They're just properties, things you can remember. Okay, and thinking back, I think I remember these when I did them for the first time. Okay, so we call alternate angles form a Z pattern. Okay, I remember seeing these for the first time because just Z, F, and C, those kind of they just stuck with me. Okay, so a Z pattern will do something like this. Okay, which basically means these contained angles here are the same. We'll call them theta, okay? Could be called theta, or like, because you're a little ahead, they could call it X as well. It's just something unknown, okay? In any event, it's just something, they're the same, I guess is the point here, okay? And then corresponding angles. Okay, I'll continue to use the Greek letters. But again, they're honestly just variables, so it doesn't matter what it is, if it's Y or X or whatever, right? This here, if this is theta, then this is theta. And this could be phi. Remember phi? Okay. That's what we call like an F pattern, if you will. Okay, you could draw an F. Everybody see the F there? Okay. So that's corresponding, and then the very last one would be co-interior. Co-interior mean this. Well, it forms a C. Sorry, I'll trace the C first, and then we'll talk about the angles. Okay. And so what this is saying is we'll have an angle here and an angle there. They're different, obviously, because they visually look different. But co-interior angles, what it says is that theta plus phi is going to equal 180 degrees. Okay, so when you add those two angles together, you should get 180. Okay, and those, I remember those way back when I was in elementary school, when I saw them. Okay, does anybody have any questions? So you're just going to try and use these to your advantage to solve for angles within some particular shape. Okay, or on what we see on the next page. Okay. Still copying a little bit? Okay, that's all right. Yeah, again, like as I'm glancing around here, you can use X and Y, whatever. That would be X plus Y would equal 180. Okay, I don't know what you're going to see on EQA. I would assume that you're probably not going to see the Greek letters. You're probably going to see X, Y, Z, something. Okay, but you need theta and phi next year. Okay, so I showed it to you. All right, any questions? We're all caught up. Go to the next page. So, we're going to take, how about I'll do these two examples, and then I'll leave the other ones for you to try, and I can take them up tomorrow. Happy to do that, okay? Does that sound like a good plan? Happy to take them up tomorrow, okay? I'll give you a head start with the first example, and then you guys can run with the other ones. That'll be kind of your homework, okay? So, when I look at them, because they're not a lot different, they get a little bit more challenging by the end, but we can take them up, okay? So, when I look at the first one, yeah, you can apply anything you want. Really, I mean, like, F might not necessarily be useful there, but you could maybe like draw it backwards. You do that. I don't know. Or you could use the co-interior angles to form the C. Or you could do, I guess my point is you could do this in any number of ways. Okay. These two would be the same. Okay. And so Y is going to equal to 71 degrees. So that's Z pattern rule. Okay. And then once you know Z, if you think back to yesterday's work, how many degrees are in the line across the bottom, this horizontal line, there would be what? How many degrees in a straight line? Aaron? Okay, yeah, it's 180 degrees, okay, for a straight line, right? And so if you know that this is, if you know that this is 71, then I can go, okay, well, x has to equal, or I suppose if you really wanted to get technical in the full explanation, you could go x plus y has to equal 180. Okay, but you know y is 71, so x plus 71 is equal to 180. Okay, so x is going to equal 180, take away 71. Okay, and what should that angle be? What's 180 take away 71? Sarah? 109, good. Okay, so if there's ever a lesson we could kind of like a little bit speedy get through, it'd be this one, okay? A couple of reasons. One, I think you've seen it before. Two, not crazy difficult. Okay, they can get a little trickier at the bottom, but I want you to try them tonight, and then when you come back tomorrow, we'll take them up. Okay. The next one, holy, there's a lot of stuff on the next one. Well, I guess it's just B and C we want to look for, right? So, let's use right off the bat. Maybe let's solve for M. Is that all right? So we'll go. How about that? I should have used the highlighter. Okay, so I'll get M. I'll use that C rule on there. Okay, the co-interior rule. Okay, and I know, because we just wrote it above, I know that those two interior angles have to add to 180 degrees. So I know M plus 65 has to equal 180. That's the definition from the other side. Okay, and so M is going to equal 180, take away the 65. And what do we get that? 180 take away 60 would be 120. Take away another 5 would be 115, right? Everybody agree? All right. Now, I think yesterday, if I'm not mistaken, we learned something else, just to do this question quickly. Or I suppose you don't even have to think of it like that. I think you could probably go if I'm trying to orientate myself properly. What do we call these ones here? So you could apply some of the other properties, I'm sure, from the front side. But I think we learned something yesterday that was like this. Or opposite angles. Okay, so you know B has to be 65, right? Because they're opposites. And then you know M has to be C, which we found to be okay? Everyone all right? Do we, Justin, first like glance here? Maybe I'll hit stop on the video.